A viral map is reshaping people's understanding of geography, revealing centuries of distortion. A striking viral image comparing Africa's and Russia's widths is upending people's geographic assumptions. It reveals Africa spans 7,200 kilometers from west to east, surpassing the 6,400 kilometers from Europe to eastern Russia. Despite this, Africa often appears smaller on maps, sparking curiosity about why this distortion exists. The familiar Mercator projection, a map many of us grew up with, was designed for sailors to navigate straight lines, not for accuracy. This causes significant size distortions, inflating countries near the poles like Europe, Canada, and Russia, while making equatorial regions, like Africa and South America, appear smaller and less prominent. Using the Gall-Peters projection, which prioritizes accurate land area representation, transforms our view of the world. Africa appears massive, dominating the map, while Western countries shrink significantly. This stark contrast highlights that the maps we rely on are far from neutral. On a Mercator map, Greenland appears nearly as large as Africa, but in reality, Africa is 14 times bigger. Greenland spans 2.1 million square kilometers, while Africa covers over 30 million square kilometers. A viral graphic stunned viewers by showing that Africa is vast enough to contain the USA, China, India, much of Europe, Japan, and more, with space left over. It starkly reveals how much of Africa's true size has been concealed on traditional maps. Since Africa straddles the equator, it undergoes less distortion than polar regions in many map projections. In projections like Mercator, areas near the poles are exaggerated, while equatorial regions like Africa should appear closer to their true proportions. Yet, distorted maps still make Africa seem smaller than its actual size. The Mercator map disproportionately emphasizes the northern hemisphere, making countries like Canada and Russia appear massive, despite being much smaller in reality. This distortion fosters a worldview where size implies importance, perpetuating Western dominance. Maps frequently center Europe, not due to its geographic position, but because early European cartographers chose this layout. Termed cartographic centrism, this practice arose from navigational needs and historical perspectives. Over time, it became standard, reinforcing the view of Europe as the world's focal point. Historically, maps served both navigational and political purposes. During the era of European empires, they often emphasized the extent of colonial territories, at times inflating their size for impact. These design choices mirrored the era's focus on showcasing dominance and exploration alongside geographic knowledge. Gerardus Mercator, a 16th century cartographer, created the influential Mercator projection in 1569 to aid sailors. While groundbreaking for navigation, it heavily distorted geographic proportions. Nonetheless, it became the standard map in the Western world, profoundly influencing perceptions of global scale and significance. For years, the Mercator projection has hung on classroom walls globally, subtly misleading students. It was selected not for precision, but due to its widespread familiarity. Gen Z is waking up to the issue. TikTok and YouTube are buzzing with videos dissecting map distortions, revealing why nations like Africa appear smaller than they are. This sparks a broader dialogue about decolonizing education. Africa spans an impressive 30.4 million square kilometers, securing its place as the world's second largest continent. With 54 diverse countries and a population exceeding 1.4 billion, this map highlights the continent's immense size and remarkable variety. Following the usual social media trend, the viral debate has spawned countless memes. The view from space changes everything. Free from the distortions of flat maps, satellite imagery captures Africa's true scale. Immense, unbroken, and breathtakingly expansive. The digital era hasn't fixed this flaw. Google Maps continues to use Mercator's distorted projection, exaggerating the size of countries near the poles. Maps lie, they can't do otherwise, observed geographer Marc Monmonier. Each one reflects deliberate choices, inclusions, exclusions, and scaling, that subtly rewrite our mental image of the planet. There's no such thing as an upside-down map, only rigid perspectives we've been taught to accept. Classrooms are finally trading those stretched old maps for projections that show Earth as it really is. It's a subtle change with profound implications. Tomorrow's leaders might grow up with a very different worldview. It's time to correct the record. Africa hosts 17% of humanity and groundbreaking innovation, yet remains cartographically diminished. Accurate maps wouldn't just show landmass, they would properly reflect the continent's demographic weight and growing geopolitical influence. Every map involves compromise. No projection can perfectly represent our spherical planet on a flat surface. However, equal area maps, such as the Eckert 4, strike a thoughtful balance. They preserve the true relative size of nations while minimizing shape distortion. More moderate than Gall-Peters, yet more accurate than Mercator, these projections provide a fairer representation of our world's geography. The Equal Earth projection developed in 2018 offers a contemporary solution that harmonizes visual appeal with geographical precision. It maintains true continent proportions while preserving a recognizable global layout, striking an ideal compromise between the Mercator and Peters projection. The Robinson projection remains a popular choice in educational atlases worldwide. While it compromises on perfect area or shape accuracy, its visually appealing representation of Earth makes it particularly effective for classroom settings, where intuitive understanding often trumps mathematical precision. In a landmark cartographic shift, National Geographic adopted the Winkel-Trepel projection in 1998 as its official standard. This carefully balanced compromise significantly minimizes distortions across all three key metrics: relative size, continental shape, and distance accuracy. The best map projection doesn't exist, only the most appropriate one for your needs. Sailors rely on Mercator's true direction maps, while social advocates prefer Equal Earth's proportional accuracy. Educators often choose Winkel-Trepel's balanced approach. The crucial lesson? Every flat map distorts reality in some way. Smart viewers always consider what's being stretched, shrunk, or rearranged.